From the beautiful South Studios of Way Happy, this is Mr. Meyer, and we are doing 1.5 parametric equations. And what are these? What are parametric equations or parametric relations? They are when you graph with a third thing involved, a third parameter. So you've always graphed x and y, right? You've plotted some points and everything's great. Well, that was fun to graph, right? When you plotted some points and you were like, hey, we're going to plot this point and then this point and then this point, and we made a line. But if we want to talk about things that have time involved, like maybe the flight of a soccer ball, I want to know where it is at every second or every millisecond, or maybe it's the space shuttle shooting off, or I guess we don't have a space shuttle anymore, but a spaceship shooting off to the space station, and I need to know where it is at every second, so therefore we can see if it's going to meet up with its target. And that involves the parameter time. So what happens is at a given time, you have to say like at 1 second, it's here, and then at 2 seconds, it'll be here, and then at 3 seconds, it'll be here, and then at 4 seconds, it'll be here, right? And that's what you do when you do parametric equations. They involve the unit time, and really that's the thing that's controlling the whole thing. So you'll notice here in example 1, we have an x equation and a y equation, but notice they're both in terms of t. So the x-coordinate, how far out you will go on your graph, left and right, is controlled by t minus 1. And how high up you go, or down, will be controlled by the y, is t squared plus 2. And that's it. That's all a parametric equation is. So notice I have these two equations, and I want to see what the graph looks like. So I will plug them in. I will plug -3 in for t and get -4. I will plug in -2 and get -3. I'll plug in -1 and get -2. I'll get -1. I'll get 0. I'll get 1, and I'll get 2. And those are all the x values. Now I'll plug in the y values. We're going to square t and add 2. So 9, 11, 4, 6, 1, 3, 0, 2, 1, 3, 4, 5, 6, and 9, 10, 11. And so there are the points. -4, 11 is on the graph. -3, 6 is on the graph. -2, 3 is on the graph, and so on and so on. And so the cool thing about a parametric equation, again, is that this is the path of something, who knows what, at a given time. So here's my graph paper. Here's my x. Here's my y. And at a given time, I will plot the points. 3 seconds ago, this thing was -3, 1, 2, 3, 4, 5. Make 5 a little darker. Oh, if you don't scribble it. 5, I'll make a little bigger. 6, 7, 8, 9, 10, and then 11. So -3, 11 is like right there, and then, or -4, 11. That was 3 seconds ago. And 2 seconds ago, it was at -3, 6. And then a second ago, it was at -2, 3. And then right now, it's at -1, 2. And then in a second, we would expect it to be at 0, 3. And then in 2 seconds from now, it would be at 1, 6. And then at 3 seconds from now, it would be back up at 211. So that's the path of something, right? A bungee jumper or whatever. And so we can follow how close they get to the ground. And there is the path that this thing takes. I missed that point. There's the path that this thing takes. And that's what parametric equations are. Again, using time to graph a function. Now you look at that and you go, wait, it's a parabola. Holy smokes. I know that graph, and you probably know it in terms of x and y. So sometimes we like to check, like, hey, could that be modeled with just x and y? Could we eliminate the parameter t out of the problem? Well, heck yeah. You've done substitution before, right? So get an equation, make them both say t equals, or get one of them to say t equals, and substitute it in the other one. So I'll take that first equation, t minus 1, and I will move the 1 over, so I get x plus 1 equals t. So now I know time is x plus 1. And then I'll go to the other equation, y equals t squared plus 2. And I will take this guy and plug it in for t. So I have y equals x plus 1 squared plus 2. or a parabola shifted left 1 and up 2. And oh my gosh, look, a parabola left 1 up 2. It's the same graph. Crazy, right? Now, you know what's even crazier? That's it. Because I was supposed to do inverses today, and I did them yesterday. So, we're done. Have a great weekend. Stay happy, and I'll see you on Monday.